If you recall at the end of 6A, we spent the time applying our completing the square knowledge, which put our equations into vertex form. We spent the time applying that into various forms of word problems, basically applying it to real life situations. And that's kind of what we're going to do right now. Some of them are less real world than others, but what you can see is that the solutions are applicable to more than just the questions you see. So for example, in some of these questions, we're going to be talking about just simple calculations, and other things it's going to be geometrical, and you're going to see that basically as long as you have the same geometrical shapes, the world still applies, or the work still applies, whether that is to a picture frame or whether it's to somebody's landscaping. It's still the same idea at the end of the day. All right, so let's get right into this. So as it says here, there are many real-world applications involving the solving of quadratic relations. There are 4 common types of word problems. In today's lesson, we're going to focus on the first 2, formula problems and integer problems. Now, formula problems are ones that we've already seen before, but now we're just applying it in a slightly different way. So, same with integer problems, to be perfectly honest. So how do we solve these things? Well, what are the steps? Here we go. Let's go here. So the steps to solving these word problems is the first thing we're going to do is we're going to create a quadratic equation. All right. So 0 is equal to ax squared plus bx plus c every single time. So quadratic equation. Now using the information provided. Now, of course, these are word problems, so we have to make sure that we include our let statements if the information isn't already clearly defined as what the variables are. Once we get there, once we have our quadratic equation, we need to solve it, which means we need to find our x-intercepts, our zeros, our real roots. In order to do that, we've learned 2 strategies this unit. We've learned how to factor and pull the information from there, or use the quadratic formula to solve the equation. Either one will work. It depends on which one is the easiest to do at the moment. You're going to find that some data is easier to work with than others. So when we're all said and done, we have to make sure that after we've checked the reasonableness of our solution, because oftentimes we'll get 2 possible answers, and one of them might be a throwaway. Other times, they may both be valid. Depends on the solution, or depends on the problem at that point. So once we've checked the reasonableness of our solutions, we're then going to provide a concluding statement of some kind, therefore, that kind of thing. So without further ado, let's get into the first problem. Let's get right down there. So we're going to start off with formula problems. So formula problems are where we already have an equation. We're trying to solve something from there. So in this case, the parabolic cross-section of an arch in front of a museum. What that basically means is you're looking at the museum and maybe there's a big door and there's an arch that covers that door basically, and there's the door handles, that kind of thing. So that's what we're looking at is the arch here. So the parabolic cross section of an arch in front of a museum is modeled by the relation h is equal to negative d squared plus 9, where h is the height and the height in meters above the ground, and d is the horizontal distance in meters from the center of the arch. From the center of the arch. So that means we're looking both directions because it's from the center here. Okay. The question is, how wide and how tall is the arch itself? Okay. So in order to solve this problem, we need to figure out how wide it is. But in order to figure out how wide it is, that means we need to know where it touches the ground. So we need to find both these locations. Well, that means that we need the x-intercepts, or the horizontal intercepts in this situation, since we don't have x and y. So how do we do this? Well, we have an equation. H is equal to negative d squared plus 9. Now we need to decide, are we going to factor this? Are we going to use the quadratic formula? Well, I know you're looking at that and you're like, wow, that looks really familiar. Can I factor this? Well, it almost looks like a difference of squares, except the problem is that it's not 2 numbers that are being subtracted, 2 squares that are going to be 2 perfect squares that are being subtracted. But it could be. What if we rearranged it? What if we rearranged it to this? H is equal to 9 minus d squared. So the 9 is still positive, and that minus that was in front of the d squared is still there. So we have 9 minus d squared. Look at that. We now have a difference of squares. A difference of squares. Awesome. So we know how to solve a difference of squares. That's just h is equal to the square root of the first term, which is 3, plus the square root of the second term, which is d. And then we have the square root of the first term again, minus the square root of the second term. So there we are. We have our factored form. And now we just need to solve this. We need to make it a quadratic equation first, which means set the vertical component, which is h in this case, to 0. So we have 0 is equal to 3 plus d times 3 minus d. Now we just need to solve for each component. So in this case, we have 3 plus d is equal to 0. And over here, we have 3 minus d is equal to 0. So we need to solve for d. So we're just going to bring that 3 over to the other side. So we have d is equal to negative 3. So the horizontal distance is equal to negative 3. That's our first x-intercept. That's actually a coordinate because we're talking about coordinates in this case. So that's negative 3, 0. So that's telling us right here, that's negative 3, 0. And what about the other one? The next one we have, well, negative d is equal to negative 3 because we brought the 3 over to the other side. Now we're going to divide both sides by negative 1, and we end up with d is equal to 3. I think I forgot to box it. Yes, I forgot to box it on this side. There we go. So that means we have a point at 3, 0. Awesome. So the question asks us how wide and how tall it is. So how could we possibly figure out how tall this is? Well, this is just a parabola. So where is the height of our parabola? It's at its vertex. So we need to figure out where this vertex is. Now, if we go back a unit, we know how to find the vertex of any parabola as long as we have the x-intercepts. So for example, here, what are we talking about? In this case, we can find the x value of our vertex by finding the midpoint between our two x-intercepts. So our x, our midpoint, is going to be equal to negative 3 plus 3 divided by 2, which is negative 3 plus 3, which is 0. 0 divided by 2 is 0. Oh, well, we could have just looked at it, to be perfectly honest. We can clearly see that, or I guess d is equal to 0 at this point, because that's pretty obvious. But we need to always show the math to verify this thing. But in order to actually know the whole vertex, we know the d component is at 0, but what about the h component? Right? So the horizontal component is 0. What about the vertical component? Where is this thing? How did we solve this before? We substituted. So let's substitute let's sub our d is equal to 0 into our equation. Remember, this is the short form for equation that I tend to use. EQN. Okay. So if our equation is h is equal to negative d squared plus 9, that's saying h is equal to negative 0. Where did it go? I lost my train of thought here. Yeah, sorry, negative 0 squared plus 9. So 0 squared is still 0, so that just goes away. So we end up with just h is equal to 9. So therefore, our vertex is located at 0, 9. 0, 9. What does that tell us? It tells us the height. We know all the information now, almost. We know the height, but do we know the width? Well, the width is just the distance from the left point to the right point. How do we get that distance? Well, the distance, or the width, is just equal to the right point minus the left point. In this case, that's 3 minus negative 3. So the width is equal to 6. So now we need our final concluding statement. Therefore, the arch is 6 meters wide and 9 meters tall. That's a big arch. All right. And that's basically the premise of all these questions. You were going to be given an equation. From there, we got to solve for the x-intercepts, the roots, the zeros, and then maybe you need to substitute some other data back in. So let's try another one. A cliff diver in Acapulco, Mexico, dives from about 17 meters above the water. So if the water is like so, and the cliff is like so, he is saying that he dove from 17 meters up. Now imagine this is our vertical axis and this is our horizontal axis. Okay? The diver's height above the water, which is in h, is measured in meters, and he is the diver's height above the water, h, in meters, after t seconds, so t is our horizontal axis, is modeled by the relation h is equal to negative 4.9 t squared plus 1.5 t plus 17. How long is the diver in the air? So basically they're asking us for time. How much time is he in the air? What is that actually asking us? It's asking us what is the time when it hits the water again. Now we had a similar problem to this in the last group of questions, but basically when the diver dives in, he hits the water again, splash, splash. What do we know? How long did it take him to get there? So if this coordinate right here is 0, 0, what is that time? Okay, so what is time when h is equal to 0? What is t? What is t when h is equal to 0? Oh, if I make h equal to 0, that's a quadratic equation. Isn't that fantastic? It's almost like this was planned. So that means that I have 0 is equal to negative 4.9 t squared plus 1.5 t plus 17. So I can try and factor this, but I don't know about you, but that looks like it'd be pretty tough to factor. So we're not even going to try. So what's our second solution? Our second solution is to apply the quadratic formula. That means we need to know our a, b, and our c. So looking at the equation, there's our a, there's our b, and there's our c. So a is equal to negative 4.9. Our b is equal to 1.5, and our c is equal to 17. So our job is to now just plug it into the equation. Now, in this case, remember that we are solving for t. So that means it's t is equal to, not x is equal to. So t is equal to negative b, so negative 1.5, plus or minus the square root of b squared, 1.5 squared, minus 4 times a, which is negative 4.9, times c, which is 17. That whole thing is square rooted, and that whole thing is over 2 times negative 4.9. Oh my goodness. Okay. Now, this is just a calculator pump. So you got to put this in your calculator twice. Now in two different situations. In one situation, we are going to be adding the square root. And in the other situation, we're going to be subtracting the square root. When you do this, you're going to end up on this side with t is approximately, because we're not going to get a perfect square root this time, t is approximately negative 1.7. And on this side, we're going to get t is approximately 2.0. What's the problem? Well, look at your picture. For t to be negative 1.7, pop, 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 that would imply that they were in the cliff, and we both know that that's not possible. So what that tells me is that this answer needs to be rejected because it's an impossible situation. Therefore, t is equal to 2.0 is our actual answer. So therefore, the diver will be in the air for 2 seconds. And that's the whole question, right? So quadratic formula is pretty quick, but it's very, very easy to make a mistake on your calculator. So get some practice with this. You don't have to do it all in one piece. You can do it in chunks. You could, for example, calculate the discriminant without doing the square root yet, and then calculate the bottom without doing any of the division yet. And then once you get it down as simple as you possibly can, then you can split it off with the plus and minus. That would probably be a better approach. but we move on. So that was our formula problems. Now we're going to get into our integer problems, which are definitely problems that we've seen before. It's just they're going to take on a slightly different form. So in these integer problems, this is where we're just relating numbers. We're just trying to figure out what the numbers are. So in this case, we have two numbers differ by 8. The sum of their squares, so they differ by 8. That tells me subtraction, and it's a value of 8. The sum, that tells me addition, of their squares is 130. Find the numbers. So we got to start off with a let statement. So let's keep it as simple as possible. We don't know anything about the numbers really. We do know that they differ. So in this case, one's going to be bigger, one's going to be smaller. But let's keep it simple. Let's just say let x be the first number. And y be the second. Number. Okay, so now that we have this, we have to look and try and come up with as many equations as we can. We did this in the last unit. So we know that the two numbers differ by 8. So that means when you subtract them, we're going to get a difference of 8. So if I say my first equation is x minus y is equal to 8, that's perfectly valid. But that's not really useful unless I isolate a variable. So we're going to isolate, the easiest one in this case would be x. So let's say x is equal to 8 plus y. So that's going to be my first equation. We have x is equal to 8 plus y. What else do we know? We know that the sum, so let's go over here. Let's do equation number 2 now. We know that the sum, so plus, of their squares, so that means x squared plus y squared, is exactly 130, is equal to 130. Well, that's useful. I got two equations, I got two unknowns, which means I should be able to solve for this. So what I'm going to do is we're going to substitute 1 into 2. Wherever we see an x, we're going to put 8 plus y. So let's put 1 into 2. There we go. All right, so that means instead of x squared here, I'm going to have 8 plus y, and that whole thing is squared, plus y squared equals 130. Yes, you have to do the work. You have to multiply it out. So what is 8 plus y squared? Now, you can do it here on the spot. For stuff like this, I like to kind of do it out on the side, and then I'll bring it in here. So for example, I know that 8 plus y squared is the same thing as saying 8 plus y times 8 plus y. So I'm going to multiply that through. So I have 8 times 8, that's 64. 8 times y is 8y. Y times 8 is 8y. And y times y is y squared. So I can simplify that into 64 plus 16y plus y squared. So I can put that right into my equation now. I could just take this whole thing and plug it in the place of that 8 plus y squared. So we have 64 plus 16y plus y squared. And then we have the original y squared, so plus y squared. And we got this 130 over here. Now remember, our goal is to get a quadratic equation. So I'm going to bring this 130 over to the left-hand side. So that means it's being added here. It means I need to subtract it. So minus 130 equals 0. Now we got to clean this up. So how many y squares do we have? We have 2 y squares. How many y's do we have? Only 16. So plus 16y. And now we have to collect all of our constants. So we have 64 minus 130. Yeah, so I think that's minus 66. Yeah, minus 66. And that's equal to 0. Great. We can simplify this because clearly we have a greatest common factor. We can take out that 2. So let's get rid of that 2. So we can factor out the 2. We end up with y squared plus 8y minus 33 is equal to 0. Now if we divide both sides by 2 and this by 2, we just end up with, so we can just get rid of those. Pop. Oh, why is it not erasing? We'll just do it manually, I guess. There we go. So that means the 2 is just going to get canceled out. We end up with y squared plus 8y minus 33 is equal to 0. Now I have to decide, can I factor this? Or should I use the quadratic formula? So that means, are there two numbers that add to 8 and multiply to 33? There actually is, pretty easy one, 33, so that's 3 and 11. Now if I look at this, this tells me that they differ, and the biggest one is a positive, so that means the 3 is negative. So that means I have y is equal to, y plus 11 and y minus 3 is equal to 0. Now I simply need to solve for each one of these values. So I have y plus 11 is equal to 0. So y is equal to negative 11. And down here we have y minus 3 is equal to 0. So y is equal to 3. Wait, how can y be two things? Why not? Is it not possible that there are two sets of numbers that actually make this math work? Yeah, of course there is. So what that means is we need to find the x values that match up with these y values. We have y's, so we need to find our x's. So what we're going to do now is we're going to sub each y into 1 to find its, highlight on the its, x value. Okay, so for the first one, we have y is equal to negative 11. So if we substitute that in, so equation number 1 is way over here. So x is equal to 8 plus negative 11. So x is going to be equal to negative 3. So that means that we have a component of x is equal to negative 3 and y is equal to negative 11. Now let's try another one. Now we have to do the y is equal to 3. So x is equal to 8 plus 3. So in this case, x is going to be equal to 11. So the sets of numbers are pretty similar, which makes sense because they relate so much. So in this case, we have x is equal to 3 and y is equal to 11. So what does that mean for my final concluding statement? It means that there's two answers. So therefore, the numbers are 3 and 11 and negative 3 and negative 11. So we came up with a situation that there are two possibilities. That's perfectly valid. There's nothing wrong with that. Okay, let's go to the next one. The product of two consecutive odd numbers. Two consecutive, which means they're one after another, but they're odd integers. So 1 and 3 would be two consecutive odd integers. 5 and 7 would be two consecutive odd integers. 111 and 113 would be two consecutive odd integers. So the product of these things is 195. There's a lot in that one sentence. So let's start off and keep it simple. So let's say let x be the first number. And, and y be the second. What does that actually mean? What is y actually equal to? Well, because they're two consecutive odd numbers, that means y is exactly 2 larger than x. So we can actually say y is equal to x plus 2. Well, that's pretty interesting. We know that the product of these two numbers, x times y, is equal to 195. So x times y is equal to 195. So we can substitute, if these are our two equations, we can substitute 1 into 2 again. So we can substitute 1 into 2, and what we end up with is x times x plus 2 is equal to 195. Ooh, let's expand this. So let's distribute that x through the brackets. We end up with x squared plus 2x. We're going to bring this 195 to the other side because we're trying to create a quadratic equation. So that's minus 195 is equal to 0. We have a quadratic. That's awesome. So we either need to factor this thing or we need to use the quadratic formula. So we're trying to find these two numbers. Okay, so let's try factoring it. It's crazy, but I know these are big numbers. So a is 1, so it is a simple trinomial. So we need to find two numbers that add to 2 and multiply to 195. So since they add to 2, that means those two numbers need to be separated by 2. So they're going to be pretty close, which means the numbers are going to be somewhere in the middle of 195's multiples. I'll give you a hint. When all said and done, you're going to end up with 15 and 13. And since they differ, the larger one is going to be the positive number, so that means the 13 is negative. So we can factor this. That means that this is going to be x plus 15 and x minus 13. And that whole thing is equal to 0. So we can now calculate each one of these. So x plus 15 is equal to 0, which means x is equal to negative 15. And over here, we have x minus 13 is equal to 0, which means x is equal to 13. So again, we ended up with two possibilities. So in order to figure out what the y's are, we know that the y is just too bigger, but we should still do the work. So we're going to sub both x's into 1. So for the first one, we have y is equal to negative 15 plus 2. So y is equal to negative 13. Okay. And then over here, we have y is equal to, 13 plus 2, which means y is equal to 15. Is that right? Yes, it is. So again, we have two sets of numbers. So therefore, the numbers are, what do we have here? We have negative 13 and negative 15. So negative 13 was the x. Not that it matters. And negative 15, as well as 13 and 15. Two sets of numbers. Okay, we're going to do one more. Final problem here. So in this case, the sum of two numbers. So the sum of two numbers is 40. Okay? And their product is 351. Oh, so this is like old school questions that we've done a bunch of times now. Let's just create our let statements and let's just get right to work. So we have let x be the first number, and y be the second. Okay, so what equations do we know? Well, the first one is x plus y, the sum of the two numbers, is 40. Okay, x plus y is equal to 40. Let's isolate for one of these variables. So let's bring the x over to the other side. So that means our equation 1 is going to be y is equal to, so that should be 40 minus x. Okay, what else do we got? Well, equation number 2 says the product of these two numbers is 351. So x times y is equal to 351. Well, let's substitute our 1 into 2. So we end up with x times 40 minus x is equal to 351. So let's multiply that through and distribute. So we end up with 40x minus x squared is equal to 351. Now, if this were a problem where we were trying to find a maximum or minimum, this is where we would put it into the vertex. But we're not trying to find the maximum or minimum. We're trying to find the actual numbers themselves. Okay? So in this case, we need to put this into a full quadratic equation, which means we need to rearrange it, and we need to bring that 351 over to the other side. So that means we have negative x squared plus 40x minus 351. And that's going to be equal to 0. Now we can factor out that negative 1. So we have negative 1 And then we have x squared minus 40x. All the signs are going to flip because we divided out a negative 1. Plus 351. And that's going to equal to 0. Now we can divide both sides by negative 1 and get rid of that negative sign completely. So we just end up with x squared minus 40x plus 351 equals 0. Now the question is, can we factor this? Are there two numbers that add to 40 and multiply to 351? The answer is yes. It's going to take you a while to find, but the answer is yes. The answers are 13 and 27. Now this tells me they're the same size and this sign, and this tells me they're both negative. So negative 13 and negative 27. If you add those up, you get negative 40. If you multiply them, you will get 351. So that means we get x minus 13 over here and x minus 27 over here. And that's going to be equal to 0. Just like before, we have to calculate both possibilities. So x minus 13 is equal to 0. X is going to be equal to exactly 13. Over here we have x minus 27 is equal to 0, which means x is equal to exactly 27. So in this situation we've calculated x, but we still need y. So we have to substitute these numbers in. So sub both x's into 1. So in the first situation, we have y is equal to 40 minus 13. So y is going to be equal to 27. Okay. And over here, we have y is equal to 40 minus 27. So y is equal to 13. Oh, wait. So that means in this situation, we have 13 and 27. And in this situation, we have 13 and 27. So just because we came up with two solutions, remember the whole question was just two numbers. There's still two numbers, but they're still the same. So in this case, they're the same. So we only have one answer this time. That is also a possibility. Remember, this goes back to if we were to put this into our quadratic formula, well, that means we'd end up with a discriminant of 0. Which means you'd only end up with a single solution. So here we go. So therefore, the numbers are 13 and 27. And that's it. So that's the end of our first day of word problems. In the next lesson, we're going to branch off and do something a little bit more practical as opposed to just number problems for the most part. That's it for now. See you next time.